Hey guys, so today in this lecture what we are going to cover is block bindings in loops. We have already seen how block bindings work with let and constants. Now let's try to explore more of it when we try to use them in the loops. But before even exploring them, let's try to see what the default behavior or how JavaScript behaves. Perhaps one area where the developers most wanted block level scoping was the use of variables in the for loop, where the throwaway counter variable should be accessible only within the for loop. Let's try to see a quick example that I already have out here. You can see that I have a for loop. I initiated the variable, the counter variable with I equals to 0, and then I just looped it till 10. And now of course if I do console log of I should be getting 0 to 9. Now the only problem is when you try to access I outside the for loop, it is also accessible even then. Now this is as against to many other programming languages where you expect that once you have the variable declared for a for loop, the variable should be available to you in the for loop, and outside the loop it's assumed that it is not available. But that's not the case with JavaScript. And that's the reason that the let and constants help you do and overcome this. So let's quickly see how let can be used. So the moment I do a let out here, this will not do anything onto this console. In fact, if I see the browser console, it should give me an exception saying that I is not defined, as you can see. Now this is a very good advantage that let added, because now your for loops are behaving the way you expect them to behave. Now that we have seen the use of variable or the let in the for loop, let's try to explore functions in the loops. Now the characteristics of var, which is var, have made creating functions inside of loops problematic, because the loop variables are accessible from outside the scope of the loop. So now consider the following code which I have already written out here, where I have a for loop and in there I have a function which I try to push a console.log of I. Now when I run this function, which means I iterate through the array of functions and I run the function or call the function, you might ordinarily expect that this code to print the numbers 0 to 9, but it outputs the number 10 times. As you can see on the console, it outputs the number 10 times. That's because I is shared across each iteration of the loop, meaning the functions created inside the loop all hold a reference to the same variable I, which means they hold the value, they do not hold the value, they hold the reference to the variable I. And when it comes out of the loop, the value of that reference is 10. Now the variable I has a value of 10 once the loop completes, and so when console.log of I is called, that value prints each time. To fix these problems, developers use immediately invoked functions expressions, that is also standard called IIFEs, which is immediately invoked functions expressions, inside of loops to force a new copy of variable they want to iterate over to be created. Let me quickly show you that, and it is actually very easy. So the thing is, we'll change this to have a value. Now once we're calling a function, let's cut this console log, we can use it later. Now inside this I'll return another function, return a function, and of course when I return the function I can do a console log of value, and here I need to make sure I pass the iterator or the I. Now if you can see, I can start seeing 0 1 2 3 4 5 6 7 8 9. So that's what the expected behavior becomes. So this version uses IIFE. Inside the loop, the I variable is passed to the IIFE, which you can see out here, which creates its own copy and stores it as a value. This is the value used by the function for that iteration. So calling each function's return the expected value as the loop counts up to 0 to 9. Fortunately, the block level bindings with let and constant ES6 can simplify this loop for you. Let's see how this can be done with the let declarations. So a let declaration simplifies loops by effectively mimicking what the IIFE does. As we have seen out here, this is an IIFE implementation. So instead, if you just want to use a let, all you will do is you will retrace back to this calling, which is out here, and of course you will just change the variable to a let. And here you can see that now the output shows 0 to 9. Of course everything works, the only change we made was let to the original implementation. And that's why this loop works exactly like the loop that was using with the var and the IIFE, but is arguably much more cleaner. The let declaration creates a new variable I each time through the loop. So you can see out here, And so each function created inside the loop, which is every time this function that is created inside the loop, has its own copy of I. Each copy of I has the value it was assigned in the beginning of the loop. Now iterating through, and the same is of course applicable for the foreign and the for of loops. Let me show you an example. So here let me create an object. Variable object is equals to, let's say A is true, B is true, C is true. So that's my object. Okay, now what I will do is I will quickly write a for loop, which is for in loop rather. So for, here I will use a let key in object, and I'll say functions dot push. Well, I can actually just change the below loop. It will be much easier. So let's do that. Let's say this is updated to key in objects. Now once I've updated that the key in objects, what I can do is console.log of key. So I can get all the keys and the for each remains the same. Let's see what the problem is. Objects is not defined because instead of object, okay, this should be object. Okay, now you can see A, B and C got printed correctly. So in this example, the foreign loop, it shows the same behavior as the for loop which we saw earlier. Each time the loop iterates, a new key is created, and so each function call or each function that was created or added to the array has its own key variable. Now the result is that the function outputs a different value. If variable were used instead of key, it will all show me all C's. Let me show it to you. So I changed everything and now everything is CCCC. So that's the beauty of let. Now, it is important to understand that the behavior of let declaration in loops is specifically defined behavior in the specification and is not necessarily related to the non-hosting characteristics that let brings to. In fact, earlier implementations of let did not have this behavior at all. So it was added later on and in the process. Now let's quickly see how constants have an effect on the for loops. So the ES6 specification doesn't specifically disallow constant declarations to be used in the loop. However, there are different behaviors based on the type of loop you're using. For a normal for loop, you can use constant in the initializer, but the constant loop will give you a warning because you're trying to reinitialize it. So let's say instead of let, if I do a constant out here, it will give you a warning or an error because you're trying to do an I++. You can see here, and assignment to a constant variable. Every time the loop runs, you try to reassign it to a variable. Now that is a problem when you use constant out there. But if you see out here in the foreign loop, when you try to use constant here, it will not give you an error. It will work as it is. It was a let. You can see I got ABC as an output, and there's no error on the console too. Now, although you're using the key as a constant, it is okay. You'll see the same output as a let. The only thing you need to keep in mind is that the let versus the constant, this key becomes a constant when you use the const keyword, which means you cannot update this key or modify this key. However, if you're using a let, you can of course play with this key attribute, whatever you're getting. Okay, so that was all about let and constants in the block bindings when you're using it with the loops.